Welcome to the deep dive. Today we're jumping into something really fascinating. Neural swarms.
Yeah, it's a really cool topic.
We've got this great piece from the Sci-Blowing podcast. Neural swarms when AI minds think together. And, some solid academic stuff too.
Mhm.
So our mission today is basically to unpack this, figure out what these neural swarms are, how they work, the potential, and maybe even get into some of the trickier philosophical bits.
Absolutely. And what's really interesting right off the bat is how it shifts the whole conversation about AI.
How so?
Well, we usually think of AI as like one super smart brain, right?
It's like a single entity.
Exactly. But neural swarms, they're about connecting lots of maybe less powerful agents together.
Yeah.
Collaboration.
Okay, so let's nail that down. Can you sort of paint a picture for us? What exactly is a neural swarm?
Sure. So think of it as a system. It's made up of many different AI, spread out.
Okay, distributed.
Distributed, yeah.
Yeah.
And each agent has, well, some level of intelligence. Partial intelligence, maybe.
Not necessarily a super genius on its own.
Not necessarily, but they work together in concert, you could say,
To do what
to
exactly?
tackle really complex problems. Stuff that one single AI, even a powerful one, just couldn't handle on its own. It's all about that collective power.
Got it. So it's more than just like a bunch of AIs doing their own things side by side. There's actual coordination happening.
Oh, absolutely. That's the core idea. And the inspiration comes from kind of two places.
Which are?
One is swarm intelligence in nature. Ants, bees, birds,
Yeah.
how they act collectively.
Right, like a flock of birds moving as one.
Exactly. And the other inspiration is neural networks, like the connections in our own brains.
Okay.
But when you put those two ideas together, swarm behavior and neural structures, you get something. Well, something new. An emergent intelligence.
Emergent intelligence, meaning the whole is greater than the sum of its parts.
Precisely. Many minds thinking together, creating something beyond individual capabilities.
And is this just theoretical, or are there actual
problem.
examples? You mentioned the Sci-Blowing piece had one.
Yeah, there's a really striking one from 2016, Unanimous AI.
Okay, what did they do?
They created this human-AI hybrid swarm. So people and AI algorithms working together, and they predicted the Kentucky Derby superfecta.
The superfecta. Isn't that like predicting the top 4 horses in the exact order?
That's the one. Insanely difficult. The odds were something like 540 to 1.
Wow. And the swarm got it right.
It did. And the point wasn't just that it got right, but how. It came from the collective input, suggesting this swarm approach could potentially outperform even individual experts or standard AI.
Aggregating different viewpoints.
Exactly. It hints at a real advantage there.
That's pretty compelling. You mentioned nature earlier. How do things like ants and bees really connect to building AI swarms?
Well, nature's had millions of years to perfect this stuff, right?
Sure.
Think about an ant colony building a bridge. There's no single ant architect, no blueprint.
Do it.
They just do it. Or bees deciding on a new hive location. They have this complex communication system, almost like voting, but it's all decentralized.
No queen bee ordering everyone around for that decision.
Nope. And bird flocks, making those incredible fluid movements again. No single leader calling out turns. It all emerges from simple local interactions.
So it's about simple rules leading to complex, coordinated behavior.
That's the essence of it. And AI researchers are looking at that and thinking, okay, how can we copy that?
For things like robots.
Exactly. Robot swarms are a big area. Think drone fleets working together or teams of small rescue bots coordinating after a disaster.
Okay.
There are projects like SwarmNet, SwarmRL. These systems show that AI agents can learn to cooperate, share what they learn, make group decisions, all without a central command post.
So they figure out the teamwork themselves.
Pretty much, yeah. Through learning and interaction.
Now, the Sci-Blowing article took this a step further, didn't it? Talking about digital neural swarms and even AI hive minds. That sounds like it goes beyond just physical robots.
It does. That's where it gets really mind-bending. Imagine not just robots, but millions of AI models.
Like chatbots, vision systems.
Yeah, chatbots, image recognition, planning agents, all sorts of specialized AIs.
Linked together how?
Through really advanced networks. The piece mentions things like neuromorphic protocols, like computer chips designed more like brains or even potentially quantum mesh networks.
Neuromorphic, so computer hardware that mimics brain structure.
Kind of, yeah. It's about building hardware that processes information more like biological neurons do, which could make these swarm connections much faster and more efficient.
Okay, wow. So millions of AIs linked through brain-like or quantum networks. What does that achieve?
The idea is they could operate less like separate programs and more like one single vast distributed intelligence. A hive mind AI.
Hive mind.
Yeah, AI that operates across different systems, different locations, constantly learning and evolving based on shared feedback, thinking collectively.
That does sound like science fiction starting to leak into reality. How would you even train something like that? The article mentioned MRL and federated learning.
Right, so MRL, multi-agent reinforcement learning, is key. That's where you train multiple agents together in the same environment. They learn by interacting, figuring out how to cooperate or compete to reach goals.
Okay, learning by doing together.
Exactly. And federated learning is also crucial. That's a way for different AIs, maybe running on different devices or servers, to learn from data locally.
Without sharing the actual raw data, like protecting privacy.
Precisely. They train on their local data, then they share the insights or the model updates they learn, not the private data itself.
Ah, like the example you mentioned earlier with doctors sharing insights about a disease without sharing patient files.
Exactly like that. So you combine MRL, federated learning, advanced networking,
Right.
and you start to see a path towards these large-scale digital swarms.
Okay, I think I'm starting to get the what and the how. Let's talk about the why. What problems could these neural swarms actually solve? What are the applications?
Oh, the potential is huge, really across the board. Disaster recovery is a big one we touched on. Imagine swarms of robots quickly and autonomously searching rubble after an earthquake.
Makes sense. Much faster and safer than humans in some situations.
For sure. And think about space exploration. NASA's actually proposed using autonomous swarms for exploring places like Europa, Jupiter's moon.
Why swarms there?
Well, it's incredibly far away, very hostile environment. Central control from Earth is just impractical. You need autonomous, adaptable, resilient systems that can work together if one agent fails. A swarm fits that bill perfectly.
That does make a lot of sense. What about closer to home? Any applications here on Earth besides disasters?
Absolutely. Think about finance or even public policy.
How?
You could have AI hives analyzing vast amounts of economic data, maybe running thousands of different models simultaneously to generate more dynamic trading strategies or even potentially crowdsourced policy options for governments to consider.
Wow. Like a super-powered think tank.
Kind of, yeah. Or imagine creative swarms.
Created like AI artists.
Yeah, multiple AIs collaborating to compose music or write stories or generate visual art in ways we haven't even thought of yet.
Okay. That's quite a range. Disaster relief to art composition.
And the common thread is their nature. They're adaptive, they're resilient because they're distributed, and they're decentralized.
Right. No single point of failure. But this also brings up those bigger questions the Sci-Blowing piece mentioned, these philosophical challenges.
They're unavoidable, really.
Like, if a swarm makes a decision, maybe a crucial one, who owns that decision? Who's
Yeah.
responsible?
Exactly. Where does accountability lie? Is it with the individual agents, the
Yeah.
designers? Or does the swarm itself somehow become the accountable entity?
And what is the swarm? Is it just a tool, a system? Or could it become something more? Like, does it have agency, an identity?
These are deep questions. We tend to think of agency and identity as individual things.
Yeah.
But a collective intelligence, it really blurs those lines. Does the swarm itself have goals, intentions?
It messes with your head a bit. The article even floated the idea of group consciousness.
Yeah, that's probably the most profound aspect. Could a sufficiently complex and interconnected swarm develop some form of awareness? Maybe not like human consciousness, perhaps something entirely different emerging from those collective interactions.
A consciousness without a single self at the center.
Possibly. It challenges our whole understanding of what intelligence and awareness even mean. It's really pushing the boundaries.
And like all powerful tech, there's a flip side, right? Risks involved. The article mentioned autonomy drift.
That's a major one. Autonomy drift is the concern that a swarm designed for one purpose might sort of evolve its behavior over time. Its goals could shift in ways the original creators didn't intend or predict.
Because it's learning and adapting decentrally.
Exactly. Its emergent behavior could become unpredictable, potentially diverging from human values or safety constraints.
And maybe amplifying biases if the individual agents have them.
That's another significant risk, yes. If the agents within the swarm are trained on biased data, the collective decisions could potentially amplify those biases on a massive scale.
So it's this balance then. Incredible promise for solving complex problems.
Collaborative, scalable, globally distributed intelligence.
But also real risks around control, predictability, bias, and these fundamental questions about what we're actually creating.
Precisely. It's not just an engineering challenge, it's an ethical and philosophical one too.
Hmm.
We need to be really thoughtful about how we develop and deploy this technology.
Yeah. This whole deep dive, it really leaves you with some big things to chew on.
Mm-hmm.
Like, is the future of AI going to be these individual superbrains, or is it going to be more about these collective swarms?
That's a central question, isn't it? Which path will dominate, or will it be a mix?
And are these swarms just a clever engineering trick, or are they like the natural next step in how AI evolves, following nature's example in a way?
You could certainly make that argument. Evolution often favors decentralized, collective strategies.
And the biggest one, maybe, are we getting close to creating a type of intelligence that's just fundamentally different from us? Something that operates in ways we can barely grasp right now?
It certainly feels like we might be. Exploring neural swarms forces us to confront those possibilities head-on. The field is still young, but the implications are huge.
Definitely a lot to think about. Thanks for breaking all that down for us.
My pleasure. It's fascinating stuff.
Absolutely. And for everyone listening, we hope this deep dive gave you a good handle on neural swarms, a shortcut to getting informed on this complex, emerging area. Until next time on the deep dive, keep thinking.